Hello all, welcome to the day 56 of the daily case study series for CBSE grade 12. The question goes like this. An aeroplane can carry a maximum of 200 passengers. The profit of rupees 1000 is made on each executive class ticket and a profit of rupees 600 is made on each economy class ticket. The airplane reserves at least 20 seats for executive class. However, at least 4 times as many passengers prefer to travel by economy class than by the executive class. Based on the above information, answer the following questions. Now, getting back to the question statement, an aeroplane can carry a maximum of 200 passengers. So first let's assume X as the number of executive class passengers and Y is the number of economy class passengers. Since the plane can carry only a maximum of 200 passengers, X plus Y is less than or equal to 200. From this it is very clear that X cannot take negative values and Y cannot take negative values. Next statement, a profit of rupees 1000 is made on each executive class ticket and a profit of rupees 600 is made on each economy class ticket. Profit of executive class ticket is rupees 1000. Profit of an economy class ticket is rupees 600. So the total profit is 1000x plus 600y. Now our main objective is to maximize this profit. The next statement says the airline reserves at least 20 seats for executive class, which means X is greater than or equal to 20. However, at least 4 times as many passengers prefers to travel by economy class than by executive class. That is, Y is greater than or equal to 4x. Now let's define the LPP. Maximize Z equal to 1000x plus 600y subject to constraints x plus y less than or equal to 200, x greater than or equal to 20, y greater than or equal to 4x, x greater than or equal to 0, y greater than or equal to 0. So this is the answer for the question 1. Second question, determine how many tickets of each type must be sold in order to maximize the profit for the airline. And what is the maximum profit? To do this, we have to convert all the linear inequalities to linear equalities, then graph it, get the boundaries of the feasible region, and then value of z and figure out which is the maximum out of this. The first linear inequality is x plus y less than or equal to 200. So we write it as x plus y equal to 200. The next one is x greater than or equal to 20, which can be written as x equal to 20. And the next one is y greater than or equal to 4x, which can be written as y equal to 4x. And x greater than or equal to 0 becomes x equal to 0, y greater than or equal to 0 becomes y equal to 0. X equal to 0 refers to the y-axis and y equal to 0 refers to the x-axis. X equal to 20 is a line which is parallel to the y-axis at a distance of 20 units from the origin. Coming to the equation x plus y equal to 200. For x 0, y is 200. For y 0, x is 200. For y equal to 4x, when x is 0, y is also equal to 0, and when x is 100, y is 400. So these equations have to be plotted on the graph. This is a graph which I have done it already. From the graph, we understand that the feasible region is ABC. A is the intersection of two lines x plus y equal to 200 and x equal to 20. Substituting this x equal to 20 in the equation x plus y equal to 200, we get y as 180. The coordinates of A are 20, 180. B is the intersection of the lines y equal to 4x and x equal to 20. Substituting x equal to 20 and y equal to 4x, we get y as 80. The coordinates of B is 20, 80. C is the intersection of the lines y equal to 4x and x plus y equal to 200. Substituting y equal to 4x, 5x equal to 200 and x equal to 40. So the coordinates of C are 40, 160. So the corner points of the feasible region are A 20, 180, B 20, 80 and C 40, 160. Let's calculate Z at each corner point. Z is 1000x plus 600y. At 20, 180, Z is 1,28,000. At 20, 80, Z is 68,000. At 40, 160, Z is 1,36,000. Out of these three values, 1,36,000 is the maximum, which implies Z is maximum at C, which implies maximum profit of rupees 1,36,000 can be obtained by selling 40 executive tickets and 160 economy tickets. If you found this video helpful, don't forget to like, share and subscribe to my channel Math with Meenakshi for more smart learning videos. See you all with another case study question tomorrow.